Hello, guys. Let's see. How do I share this over here? Um, Here, can I open Sketchpad? Okay, cool. There you go. I like that. Here, so, you guys can sketch that. Cool. Let me see if that's all you guys see. Gotta put. Odd, why can't you guys see it? Oh, there we go. But if I Cool. Okay. Awesome. Awesome. All right. So, hello, friends. Today I'm going to be doing calculus while eating Takis and drinking Pepsi. I don't know the name of it. It's fine. Yeah, right now I am doing like a practice exam. So I have like a timer of 2 hours, but we're probably gonna finish in like 30 minutes. I've done already like three of these. And so the thing is that you guys are just gonna see this sketch pad over here because I can't share my screen showing these problems. Apparently that's considered plagiarism and or not plagiarism. Uh academic I mean it's something to do with academic integrity, and I don't want to break that. So I'm just gonna write the problems here. Apparently that's what I can do. So yeah, we are everything what we're doing here is valid. So we're gonna begin. Uh, we ready? Yeah, I don't even know if anyone's gonna watch, but here we go. We need the stimulation from talkies. I think I've barely tried these before. I've only tried them one time in my life, but that's it. All right, here we go. So start assessment. Here we go. So I am given um whoops. I'm given f of t. Can he draw with my hand? Oh wait, I probably can actually. Can he do this? Oh, that's actually really cool. Oh guys, watch this. So we have f of t equals, we have sine of t over 6 plus 6 over t. I think that's what we have. And we need to determine f prime of t. Can we like change the background in this thing? I don't like it. It's a little distracting. Select, we want to, whoops, nope, we don't want to do that. Oh, we're bound to, okay. Text. Whatever. All right, I think this thing is limited. All right, cool. Whatever. So, the way I see to do this here, I could zoom in. Yeah. All right. So, where's the eraser? I should have prepared this before. There's no eraser. Can you like get rid of all of that? Oh. Oh boy. Okay. That's fine. So we have. Let's get back. So we have sine of t over 6 over t. So the way I like to view this um is in terms of our input. So we have t as the input, so that's our function. Um, but here we have two quotients, so our first instinct would be to apply the quotient rule. However, we can't do that. I mean, we won't do that because t is not on both the numerator and the denominator. We only have t on the numerator and we only have t on the denominator here. So we don't have it on both of them. So we can't apply the quotient rule. But that's cool because then it makes life so much easier. So I mean, I'm guessing the way to do it is rewriting this as sine of t times 6 to the power of negative 1 plus 6t to the power of negative 1. Oh, and all of this prime. What we did is simply copy the entire function in another way. That's what we did. So now we simply want to rewrite this. All right, how about this? We eat Takis when we get the problem done. And we have what? Like, we have 16 problems. All right. We don't want to spend too long in this because this looks pretty easy. Let's see. So we have what do we have? Let's okay. Yeah, so looks I think we do so we have cosine of t and the derivative of 6 to the power of negative 1. I mean, that's just we just keep that there plus so then to the of negative 1. So okay, so this is actually a negative right here. That's not a positive. We have a negative 6t to the power of negative 2. I mean, I think that's what we have. So guessing we're just going to plug that in. I mean, I have a feeling that I'm doing something incredibly stupid right now, but it's fine. I mean, I think I'm getting this right? That's right. Perfect. Yeah. Yeah. So what we did is simply rewrite the expression in a way we can understand it better to differentiate. And we simply applied the derivative, and there you go. And that's what we have. Perfect. Okay, now we have, all right, let's see the talkie because that's the title of the video. So, okay. That's good. It's actually pretty good. And I'll see what's all the commotion going on with talkies and all of that. Here. Now we got to erase all of this, dude. How do we do that? Oh, dude, I'm sweating now. Whoa. It's not that hot, but I'm sweating because of these talkies, dude. I shouldn't be drinking this, but all right, it's fine. It's just one day. Okay. Let's see. How do we erase this, bro? How do we do this? All right, we want to erase this. Oh, how? How do we erase it? Okay, dude, I'm wasting a lot of time here. I don't want to. Dude, how? Oh my goodness. Factor fill? Why did I have to do it so big? Oh, hold on. Wait. What if I do like that? And I just but no, I don't want to do that. Whoa. Dude, I mean, there got to be a way to delete this. Oh, there is a way. Let's go. Hey, we did it. Let's go. We finally did it. Awesome. Let's continue. So let's just zoom in over here. Excuse me. What are the settings? We need to. Oh no. No, dude, I don't just want white. All right. So we have wait, what if I move it like that? Still, right? Cool. Over here. But I'm still streaming all of it, right? So, dude, I'm just gonna like wash my hands. There we go. So much better now. Okay. So, yeah, I'm not going to write anything here. I think I'm just going to write it here. All right. So, we have f of x equals -7 over x. That's what we're given. Then the expression f of x plus h minus f of x over h can be written in the form a over x plus h, where a is a constant and a equals blah, and we have to type that in. Oh, so here's the thing. I think I remember doing a trick that got us here. So we plug this into the a definition of the derivative. So our definition of the derivative is f of x plus h minus f of x over h. Then what we do is now just a replace. So we have -7 over x plus h. Yeah, that's just f of x plus h minus -7 over x. All of this is over h. Can we move? Then this is equal to what is this equal to? Yeah, so we could just simplify. Let's make this a little neater. Plus 7 over x and all this over h. Now, I mean, let's see. I mean, we want to get something a over x plus h. So I'm just going to multiply by x over here and by h, x plus h over here. So here's what we're going to do. We're going to multiply by x on this first term. So we have -7x, x plus h over here, x plus, and then we're going to multiply x plus h on the second term. So we get 7 times x plus h over x times x plus h. So what we did here is simply multiply by 1 on this first term and multiply by 1 on the second term. I mean, yeah, so that's completely valid. It's equal to what we here we have above. Oh, and obviously over h. So now, let's continue. So, I mean, just multiply by the reciprocal. This can be seen as h over 1. So what we can do is now have, yeah, that's equal -7x x plus h over times x. What am I saying these days, bro? Plus 7x plus h over x times x plus h. Beautiful. Times, so I'm just gonna put parentheses over here, times 1 over h, because we multiplied by the reciprocal. Here we had h over 1, and now we have 1 over h. No, yeah, I mean, we can join the functions together. So I'm just gonna zoom out a little bit, and we now get -7x plus 7x plus h all over x times x plus h times h, because we multiplied that h. And this is equal to, well, I mean, I guess we can now replace, because we need to cancel that h or else we won't find a. So we get negative 7x plus 7x plus 7h over x times h times x minus h. This is equal to, so negative 7x and 7x cancel. So we only get 7h over x h times x minus h. And yeah, now here we can just get rid of the h's, just cancel. We get something simple like negative 7 times x plus what? Why do we have a minus h over there? That's actually kind of weird. Yeah, we have plus, plus, plus. Oh, whoops. Yeah, this plus. This is plus h. This is plus h. Yeah, that's odd. Hold on. Oh my goodness, what did we do? Yeah, no, minus h. Perfect. Yep. And here we have plus h. And here we're supposed to have a plus h as well. So we have 7 over x times x plus h. So our a is 7. Using your answer from above, we have limit of f of x plus h minus f of x over h as h tends to 0 is oh, so now we just type the entire thing in because that's what we get, literally. Now, evaluate f prime of 1. So I'm just gonna get rid of all of this because it's so ugly. And we're gonna eat another Taki. Okay. Whoa. So we have we have f prime of x. That equals, excuse me, equals 7 over x times x plus h. That's what we have. We need to evaluate f prime of 1. So that equals, well, 7, 1 plus, whoa, wait, hold on. Why do we have h? No, that's good, right? Oh, it's h tends to 0. My bad, I forgot. So, yeah, as h tends to 0. So we simply replace h with 0. So we have 7 over, well, yeah, 1 times 1 plus 1 times 0, which is 0. That's simply equal to 7 over 1, or 7. F prime of 2 equals 7 over 4. 7 over 4, right? Yeah, it didn't do anything. 2 times 2 is 4 plus 2 times 0 is 0. And finally, f prime of 3, we have 7 over 9. And did we get that right? Whoa. Oh, okay. We got everything right except our definition of the limit. What happened, bro? It's not 7? I'm sorry, I'm confused. We got everything correct except our definition of the derivative. Oh, wait, hold on. What happened? Oh, my bad. I forgot to replace h with 0. So we have, what, like x squared or something? I mean, 0. Yeah, we simply have x squared. Beautiful. All right, we got that right. My bad. All right. So now to the third problem. Here, now I'm just gonna. Can you guys see okay? We're cool. So looks like we have. Here, I'm just gonna eat another Taki. Okay. Well, it's gonna. Chill, bro. So we have So they're asking us to determine the slope of the line tangent to the graph. So in other words, find the derivative of product rule time. That is sine of x. Hold on, I'm just gonna get closer. Oh, hold on. So, sine of x. Oh, whoops. Sine of x times sine of x plus derivative of sine of a cosine of x times cosine of x. Well, wow, that's so ugly. I'm not even sure you can understand that. It's fine. I can't even understand it. So we're good. So -6 times negative sine squared of x plus cosine squared of x, or 6 times sine squared of x plus cosine squared of x. And we're supposed to evaluate it at x equals 0. So we have equals 6 times sine squared of 0 plus cosine squared of 0. And this equals 2. 6, wait, what do we have? Yeah, 6 times, oh my goodness, we forgot a 6 right here, and we've got a 6 right here. And sine squared of 0, let's see. So sine of 0 is 0. So we don't have that. That's all of this entire term is literally 0. And 6 cosine of 0, well, cosine of 0, cosine squared of 0, and cosine of 0 is 1. And 1 times 1 is 1. So we only have 6. We have 6. We'll get that right under first. We got that wrong? What? So confused, bro. I see. So we're supposed to have a negative right here because we multiplied it by -6, not 6. So we have there. Yep, so this should be -6. All right, we got that right. Oh, dude, wow. I'm not sure if Takis is increasing my productivity or not. That's pretty good overall. So let's get rid of this. All right. So consider the function f of x. Whoop, this is moving a lot. Equals 3x minus 9 over -9x minus 8 times 9x minus 8. 9 this time. Yeah, I got that right? Yeah. All right. Enter the equations of the vertical asymptotes. If there are no vertical asymptotes, enter none. If there is more than one, enter a list of the equations separated by a comma. Okay. Ooh, that's hot. Oh yeah, that's kind of hot. No, I was kidding. Oh yeah. So we need to find the vertical asymptotes. So these are the values of x that make the equation go to 0. So what values of x make this equation go to infinity? What values of x make this equation go to infinity? Well, that means we need to have the denominator equal to 0, and something over 0 is like undefined or infinity. I mean, I think either one counts. So x should be, well, -9 times what is 8, because 8 minus 8 is 0. That'll be negative 8 over 9, I think. Because then if we replace, the -9's cancel and we get 8. Beautiful. And then we also have x equals what? Huh. Whoa. Excuse me. Uh we're going so slow. I mean, oh wait, no. Sorry. This is a positive. Yeah. All right, cool. So we have negative 8 over 9, comma, 9 over 9. Or 1. 1. Yeah. Whoops, and we're supposed to do x equals, comma, x equals. Beautiful. Okay. So that's that. Now we're supposed to enter same thing. So horizontal asymptotes, what are they? No, and I don't think I care. I'm just kidding. Yeah, values. No. I'm sorry. When x goes to infinity, what do we get with f of x? I think that's what we get. So, I'm just gonna expand. Just for fun, because why not? If 3x, no, just kidding. Yeah, we're going to expand because we need to observe some like a relationship in the polynomial, especially here in the bottom. I think so. Negative 9x times 9x is going to be negative 81x. Negative 9x times negative 9 is going to be plus 81x. Hold on. What are you doing? Yeah. Oh, what am I doing, dude? Negative 9x times 9x is negative 81x squared. Negative 9x times negative 9 is 81x. Um, and then we have negative 8 times 9x. That's negative 72x. And then negative 8 times negative 9 is 72 plus 72. So this equals 3x minus 9 over negative 81x squared plus, well, 81x minus 72x, that's what, like 9x plus 72. So I remember that I guess you can observe, whoa, what am I saying? Observe the behavior of the function by just looking at the, how do you say this? The x's with the highest degree and its coefficients. So we get like 3x over negative 81x squared. Yeah, and I guess that makes intuitive sense, since if you plug in infinity, well, this x at the top and the x squared at the bottom won't really, I mean, they will surpass all these other x's. So I guess that makes sense. So the horizontal asymptotes. So yeah, when x goes to infinity, will basically, I mean, sorry, not my bad. This entire function goes to 0 because x squared will go much higher than x. Yeah, so positive infinity, right? I think that's the answer. Oh, hold on, but we have a negative 81. We have a negative 81, bro. So well, like a negative infinity? Hold on. That's kind of confusing. Hmm. Um Hold on, dude. Okay, I think I'm done eating. Okay, so when you plug in infinity, you get like 3 times infinity over negative 81. All right, let's just say infinity over negative infinity squared. Yeah, so we have like infinity over negative infinity squared. Yeah, so we're making negative the infinity squared. So that's basically negative infinity, I think. Huh, what? says doesn't work. Oh, dude, that's hot. Operands of equal must be numbers. We say you can't. Does oh, oh wow, dude, this question always stumps me up. Okay. Let's see. Why isn't this working? It says the answer can't be submitted in the way I wrote it. So, huh? I mean, yeah, obviously y equals a negative infinity. How do you put that though? Should I put? Oh, I should have put that. Hold on, or what if I put this? Dude, okay, man. Oh, what's going on? Oh, hold on, wait. No, that's not going to infinity. That's going to 0. What am I doing? There we go. Yeah, that's going to 0. Yup, there we go. My bad, guys. My bad. That was not smart. All right, it's fine. Let's continue. All right, we're going way too slow. Or I'm going way too slow. I got to go faster. I know, guys. I know. Excuse me. Okay, I don't know what's going on today. All right, so we have the limit as x tends to negative infinity of 11x plus 3 over 7x squared minus 9x plus 11. So evaluate the following limits. If needed, enter inf for infinity and negative inf for negative infinity. So let's see. So this is a horizontal asymptote, I think. So we can basically just, since we're dealing with infinity, we can simply observe the behavior with 11x over 7x squared, the terms with the highest degree. Let's see. So that's what we. Oh no, that's not right. That's not right, guys. I don't do this mistake. We still have the limits. Limit as x tends to infinity of 11x over 7x squared. That's what we have. So as x tends to infinity, we'll probably tend to like 0 or something, right? Yeah, that's 0. And then the part B is the limit as x tends to negative infinity. So, well, yeah, I mean, the same function, same behavior. So we just do negative infinity at the top. Oh, well, I mean, yeah, sorry, we have like a negative infinity over infinity because a negative squared is positive. And that's still negative. Oh, but that's like negative 0. So that's still 0, right? And that's right. We're cooking. Let's go. You guys, I don't know why I'm eating Takis. I thought it would be cool advertising, but there's no health inspections, so that's not cool. Okay. So we have f of x equals x squared plus 8x plus 12 over 4x plus 8. By the way, guys, let me stop it. Am I looking fat because I ate the Takis? I feel fat. Oh, what happened? To my hair. I don't know why. Even when I take a shower after going to swimming, my hair is still like sticky and all. Whatever. So we have f of x equals that thing. So we need to evaluate f prime of 3 and then f prime of 3. So what we do there, first, what I'm going to do is simply evaluate f prime of x. So we clearly have like a quotient where the denominator and the numerator are functions. So we're going to do the quotient rule. Let's go. Okay. Gotcha. Okay. So let's do it. So we have f prime of x first. So we have 2x plus 8 times g of x. So we have 4x plus 8. Minus f of x, which is squared plus 8x plus 12. Uh-oh. All right. Yeah, whatever. Times 4x plus 8 prime, which is simply 4. And this is all over 4x plus 8 squared. Well, dude, we are using up a lot of space. Whatever. Yeah. Well, that's basically it. So I mean, we could simplify to get 8x squared plus 16x plus what? A 32x plus 64, and we'll simply get 48x plus 64. 48x plus 64 minus, oh, we got to be careful with this one. Yeah, I'll just put that. 4x squared plus 32x plus, is that a 12? Oh, that's a 12. Plus 12, 24, plus a 48. Or I mean, we can remove these parentheses and replace all of these pluses with a minus. Whoops. Sorry. This. There we go. Negative 4x squared minus 32x minus 48. That's what we have. And this is all over. Oh, no. No, no, no. Let's not do that, bro. This is all over 4x plus 8 squared. I could expand that, but I'm not going to. Yeah, now we just gotta replace 3. So I'm just gonna take all of that off. Because why not? Yeah, so let's just put f prime of x right here. Beautiful. Now let's put f prime of 3. What is that? What are we doing? No, dude. F prime of 3. This equals this equals 8 3 squared plus 48 3 plus 64 minus 4x squared. Is that what we have? For real? Yeah. 4 3 squared. No, dude. Stop. Minus 32 3 times 3 minus 48. Oh, and this is all over 4x plus 8 squared. So this is equal to 8. Oh, no. What are we doing? So 3 squared is 9, and 9 times 8 is 72. 72 plus 144 plus 64 minus, so 9 we have 9 times -4. So that's plus 36 minus 96 minus 48 over 4x plus 8 squared. I'm just going to delete this. Cool. Oh. Cool. So, we have that. We could use a calculator, and that's what we're going to do. Desmos. So we got what? So we have 72 plus 144 plus 64 plus 36 minus 96 minus 48. And all of that over, oh, whoops. And this is 3. So this is 12. Not 43. We have 12. 12. So that's 20. 20 squared over 20 squared. And, oh, you're going to give me a decimal? And in fact, no. I'm not going to write that. Sorry. I'm not going to put 0.43. I'm just going to put 72. Oh, wait, hold on. Plus 144 plus 64 plus 36 minus 40. Oh, my bad. Minus 96 minus 48. I mean, I have a feeling that I got so many things wrong here. I hope I didn't. 20 squared. That's what we have. And then the derivative of that, well, oh, wait. Okay, I have a feeling we did everything wrong here. Why do I still have squares? Oh, no. I think that's good. Oh, boy. Are you sure? Oh, what are we doing, dude? Hold on. F prime prime. I mean, we get 0 here, right? Yeah, that's not. Oh, F prime prime was 0. Here, let's do this again. So, we are given. How long do we go? Yeah, we go 43 minutes. So we go f of x equals x squared plus 8x plus 12 over 4x plus 8. F prime of x equals, according to the quotient rule, we get 2x plus 8. Then times g of x, which is 4x plus 8, minus, let's just have her, let's have her denominator ready, minus x squared plus 8x plus 12 times 4 all over 4x plus 8 squared. That's the derivative. And in fact, I think I'll just plug that in. I should have simplified to get a practice. However, I think I'm spending too much time on a single problem. So 4x plus 8. Yeah, I hope I did this right. It looks good to me. Okay. Got that wrong? Why? Oh, no. Oh, we're so dumb. Oh, okay. I forgot to reply. What? To oh my goodness, dude, I'm losing my words. I forgot to replace. There we go. I forgot to replace 3 with X. That sucks. Okay. It was fine. Here, let's. So, we have we have to evaluate the limit of square root of x squared plus 7. Whoops. X squared plus 7 minus the square root of x squared minus 5 as x tends to infinity. That's what we must do. So, here I'm just going to expand this. There we go. That's much better. So, this equals, how can we simplify? Oh, I mean, in fact, this is really easy. Just, all right. Well, let's see what happens. So the square root of infinity is still infinity. So the square root of, all right, other 7 is negligible and that negative 5 is negligible. So we have infinity squared, we have the square root of infinity squared minus the square root of infinity squared. Yet we still have, but we know that this one is bigger because this is plus 7 and this is only minus 5. I don't know what to do. Is the answer 0? Because they're going to be really similar, right? Yeah, the answer is 0. Okay. Let f of x, so we have, f of x equal 4x when x is less than or equal than 2. And we have f of x equal x squared. Oh, dude, that's so ugly. X squared. Come on, man. Let's try a good x squared. There we go. X squared when x is greater than 2. Find each point of discontinuity of f, and for each, give the value of the point of discontinuity and evaluate the indicated one-sided limits. Okay, so point 1. The limit of f of x as x tends to c, let's draw that a little better, tends to c, what? Tends to c from the left. So, c, wait, what is c? Wait, what is c? Oh, okay, the point of discontinuity. Oh, well, yeah, obviously the point of discontinuity is 2 because our function changes there. Um, let's see. So this is going to equal, well, from the left, I mean, so I'm imagining that it goes like 1.9, 1.99, 1.999, all the way until 2. So that's obviously coming from less than 2. So we're going to have 8. Yeah, we have 4 times c equals 4 times 2 equals 8, right? Yeah, that's simple. So that's 8. Now we got to evaluate it from the right. Ooh, oh my goodness, dude. It's fine. Whatever. From the right. Oh, okay. That's it, dude. We can't. From the right. Perfect. Well, yeah. That's going to be greater than x equals 2. So this is going to be 4 because x squared 2 squared equals 4, right? I hope I'm not doing anything wrong. All right, and yeah, I think that's the only point of discontinuity we have. So I'm just gonna put X on all the other boxes. Yeah, I think that's right. Yeah, we got that right. Let's go. We're cooking. Good job. Good job, guys. Let's see. Use interval notation to indicate where f of x equals x minus 8 over x minus 4 times x plus 4 is continuous. Okay, gotcha. Well, luckily they give us two binomials over here. So this function will equal, will not be continuous, will be undefined when x equals 4 and x equals negative 4. So that means that our interval will go from negative infinity all the way to negative 4, union negative 4 to 4, union all the way to 4 to infinity. And that's our interval. So let's write that down. We have negative infinity, comma, negative 4. Kamala, what? No, I don't want to get political. I'm going to get banned. What's going on? What? No, stop. Comma 4. Comma 4. Union 4, comma, infinity. Yeah? Let's go. Good job, guys. Let f of x equal 2 tangent of x over x. And no, we can't simplify x because x is the input of tangent. Find, oh yeah, I'm just going to put this then. Find the following. That looks like a proof, a function. Find the following. So we have to find f prime of x and then f prime of 3. Perfect. So f prime of x, it's really easy since we have x and tangent of x on the numerator and denominator, on denominator and numerator respectively. So we just do the quotient rule. So we do 2, that's secant square root of x, and x minus 2 tangent of x, and the derivative of x is 1. And then all of this is over x squared. So that's our derivative. And then, so thus f prime of 3 is going to be 2 secant square root of 3 times 3 minus 2 tangent of 3 over 9. Right? Yeah. Just making sure I'm not missing. Oh, perfect. Yeah, I can simplify over here. Yeah, equals 6 secant squared of 3 minus 2 tangent of 3 over 9. Let's go. Okay, so we plug that in. Secant squared. Guys, am I sounding like a boring professor? I hope not. I don't want to sound like a boring professor. Over x squared. Beautiful. Now we plug in 3 and we get 6 secant squared of 3 minus 2 tangent squared. Oh boy, wait. A tangent, of 3. Phew. Over 9. Oh, what? We got f prime of 3 wrong, but we got f of x. F prime of x correct. Let's see. So we plug in 3. Okay. That looks good. Excuse me. 2 tangent of 3. Okay. 3, 3, and 3, and 9. Okay. So 3 times 2. That's going to be 6. So we have 6 secant of 3. 6 secant squared of 3. Why? Okay, I see what he got wrong. Why did he put tangent squared? That's not right. Right. Looks correct. Perfect. All right, we got that right. I should have named this video "Why Eating Takis Makes You 10 Times Less Unproductive." You guys don't eat Takis while doing math. I see it's not good, but it's fine. Everyone has their own preferences. So I need to determine the limit of 2x minus 4 over x squared minus 4 as x tends to 2. If the limit does not exist, enter DNE 4. I mean does not exist. My bad. So oh well, here's the thing. With these limits, if the function is already simplified the most they can be, well, you can simply plug in 2 and that's your correct answer. However, if your function is not simplified, meaning like you can factor or anything or cancel some number or like some term, then if you plug in 2, your answer is going to be wrong. So always make sure to simplify as much as you can. My computer is gonna die. Somebody turn off the lights. Not good. What? There we go. That's working. Okay. Perfect. So, let's see. What can we simplify? Well, oh, nice. We got a difference of squares over here. We have x squared and we have 4. So, 2x minus 4, hang on a minute. I don't know how I'm going to factor you. What I see is that we can do x plus 2 times x minus 2. Yeah, if we expand that, we're going to get this. Yeah. How do I cancel anything here? I don't know. Oh, wait. All right, whatever. X minus 2. There we go. Perfect. Let's make a better line. There we go. 2x. So how can we factor this? Well, we can factor 2, I think. X minus 2. Oh, nice. Would you look at that, guys? So we can cancel x minus 2 and x minus 2, and we get 2 over x plus 2. Let's go. And now what we can do is replace 2x with 2 because we can't simplify anymore. 2 over 4 or 1 over 2. Let's go. Let's go. We got that right. All right, we're in question 12. We have 4 problems left. Well, 12, 13, 14, 15, 16. We have 16 problems left. Sorry, we have 5 problems left. Oh, 3 people are watching. 2 people are watching. Oh, what's up, guys? It's good to have you here. We're just doing math. So, thanks for joining. Suppose that f of x equals 7x squared plus 7x. Find f prime of x. Yeah, so this is like a 4-part problem. So this is part A. F of x equals 7x squared plus 7x. Determine f prime of x. Well, per the power rule, we get 7 times 2x plus 7. And this simply equal 14x plus 7. Right? Yeah, I'm not missing anything, right? 14x plus 7. Now, the slope of the graph of f of x at x equals 2 and x equals 3. Oh, so I have to determine that. So yeah, so I have to determine the slope of the graph of f of x at x equals 2 and x equals 3. Yeah, so the derivative is a slope. So we already have our derivative. So we just plug in 2. What? No, that's not what you do, silly goose. And then f prime of 3. There we go. That's what you do. Gosh. So we do 14 times 2 plus, dude, I feel like this is a little easy. 20 plus 7 equals 35. Whoops. What am I doing? Okay, here, let's rewrite that. What is going? What? No. Pencil. There you go. Huh. Why is that going on? $35, right? So we get 35. Why does that happen? Huh. Alright, I guess I'll just have to write with my finger. Not very efficient, but it works. So, come on, dude. Hold on. Okay. Yeah. Dude, stop. What's going on, bro? Oh, why is it moving up? It's not supposed to do that. Weird. Okay. All right, we have 14, 3 plus 7. And that, let's see, 42 plus 7 is 49. 49. An equation for the tangent lines at x equals 2 and x equals 3. Okay. Why can't I write with this thing, dude? Can I refresh? Oh, awesome. Let's go. So we're going to use point slope form. Y minus y1 equals m times x minus x1. So y minus, whoops, y minus y1. What's y1? So here's the thing. They're telling us to find the equation of the tangent line at x equals 2 and x equals 3. So they're giving us the x, but now we have to find the y. And this is really easy. Simply plug in the x's in our original equation. So I think like our original equation is f of x equals a 7x over here, 7x squared plus 7x. So we simply replace x with 2 in that equation. So we get 7, 2 squared plus 7 times 2 equals, oh, whoops, and this is going to parentheses, equals m times x minus 2, because we're going to find the equation of the tangent line for x equals 2. And this is equal to, well, y equals to m times x minus 2 plus, and we're just going to add all of this up, plus, so 2 squared 4, 7 times 4 is 28, 28 plus 14, and 20 plus 14 is simply 42. Yes, so that's it. Oh, my bad. And m, here I'm just going to, we found m. The derivative of the function at the point x equals 2 is 35. So 35, that's our slope. Perfect. So we plug that in. Y equals 35 times x minus 2 plus 42. That's our equation of the tangent line. Y equals mx plus b. Beautiful. Now we simply got to do that for the tangent line at x equals 3. So in fact, I'm just going to, what am I going to do? I'm just going to take all that off. Okay. So now we do y minus, so we're replacing 3 in our original function. We get 7 times 3 squared plus 7 times 3. equals mx minus x1. So that's going to be, what's m? M is, all right, this looks like it's supposed to be 49, I think. 14 times 3, 42 plus 7, 49, right? So a 49 times x minus x1, which is going to be 3, right? Yeah, 3. And so that therefore y equals 49 times x minus 3 plus, um, so 3 squared is 9. 7 times 9 is 63. 63 plus 21. And that's equal, so therefore y equals 49 times x minus 3 plus, so 63 plus 21 is going to be 84. Okay, let's go. 49 times x minus 3 plus 84. Perfect. Now, finally, part D lists all values of x where the tangent line is horizontal. So, this is really easy. Just find the values of x where the slope is 0. Horizontal, this is slope 0. So, gotcha. So, where's our equation for our derivative? Whatever. We have a 14x plus 7. So list all values of x where the tangent line is horizontal. Okay. What do we do? Hold on. Gotcha. So to do this, we simply find the values of x where this is 0, where the derivative of 0 is a 0, and thus where the slope is horizontal. So let's see, when x equals 7 over 14, negative. So when this happens, 14 and 14 cancel, and we'll have negative 7 plus 7, and that's 0. Yeah, I think that's it, right? Negative 7. Is that the only value? I think that's the only value, right? All of them right. We're going incredibly slow, but it's paying off. Perfect. All right, we're in question 13. We got 4 problems left. Incredible. Okay, well, we have f prime of x equals, sorry, not f prime, simply f of x. F of x equals x plus 3 times x squared plus 7x plus 5, and that's it. So we need to find f prime of x. Yeah. All right. Product rule equals. Oh my. Why is this slanted? F prime of x. Oh, let me just. What are the ingredients in here? We got total fat, 0 grams. Sodium. Oh, you guys want to hear something interesting? You know, I was taking a chemistry course, but it got too busy, so I dropped out because I couldn't really do all my classes. Yeah, and that's it. Thanks for listening. All right, let's get back. So, come on, let's get some stimulation. You know, Winston Churchill, he said that he drunk 6 cups of vodka a day for intellectual stimulation. But no, I don't plan on drinking 6 cups of vodka. I don't think that's very healthy. All right, let's get back. So this equals 2. X plus 3. Well, times, nope. 2x plus 7 plus 1. Oh, wait. F of x times g prime of x plus f prime of x. Yeah, 1 times g of x. So just type that back. Plus 7x plus 5. Yeah, simple product rule. We could simplify, but we don't have to. And yeah, I don't think it's worth it. X plus 3 plus times 2x plus 7 plus x squared plus 7x plus 5. A lot of pluses, no minuses. Let's go. Beautiful. Okay. We got 3 questions left. It's gonna sketch the graph of the following function and use it to answer the following questions. All right. So we got f of x equals. What's that, bro? There we go. That's better. Okay, let's make that a little bigger. Not that either. There. How do you draw these things, dude? Okay, I think I like that better. Here, I'm just. Beautiful. That's so much better, actually. 4 minus x when x is less than 2, less than negative 2. F of x equals x when x is in between negative 2 and 6. And finally, f of x equals x minus 6 squared when, oh, dude. Here, I'm just gonna. X minus 6 squared when x is greater than 6. So f of x equals 4 minus x when x is less than negative 2. Yeah, okay, we get it. Calculate the following limits. Okay, so first we got limit of x as x. Sorry, the limit of f of x as x tends to 2 from the left. So, 2 from the left, in other words, less than negative 2. So, yeah, tends to 2. So this is 4 minus 2 equals 2. Let's plug that in. Take that out. Next limit. The limit of f of x as x tends to 2 from the right. Well, that tends to negative 2 on the right. I'm sorry, negative 2. And the other one was negative. I didn't put it, but it's still correct. We're good. As x tends to negative 2 from the right. So this is going to be in this section right here, this one. So simply going to be 2, right? X equals 2. Easy. Equals 2. And therefore, the limit of f of x equals, sorry, the limit of f of x as x tends to negative 2 is 2. And the reasons why, from the left, the limit was 2, and from the right, the limit was 2. Therefore, because the function is continuous, the function is, because it's continuous, the limit exists. So this equals 2. All right, and the other limit they want us to evaluate is going to be the limit of f of x as x tends to 6 from the left. All right, this is easy. This is going to be less than 6, so it's going to be in this range as well. So this is simply going to, whoops, not there. This is going to equal 6. Yeah, all right, let's go quicker. Let's get that out here. And then the limit of f of x as x tends to 6 from the right, that's going to be greater than 6 over here. So x minus 6 squared equals, this equals, equals 6 minus 6 squared. Is that right? Yeah. 6. Oh, no. No, it is. My bad. Yeah, 6 minus 6 squared equals 0. So what that shows is that, so yeah, from the right is 0. So therefore the limit does not exist, because from the left it was 6 and from the right it was 0. Because they're not equal, well, the limit does not exist. What? All right, we got our last 3 wrong, but we got the first 2 Sorry, we got the last three right, but we got the first three wrong. And why is that? So we have the limit of f of x as x tends to -2 from the left. So that's going to be, oh, my bad. 4 minus -2. This is 6. My mistake. Then we have from the right, so that's going to be -2. So this is -2. Oh, so therefore the limit does not exist. Beautiful. We got all of that right. We have two questions left. Oh, let's go. We're cooking. Good job, guys. We have f of x as 6. Sorry, not as. F of x equals 6 over 6x plus 5. Therefore, f prime of x is going to equal. Yeah, so no quotient rule here because we don't have a function in the numerator right here. So we have 6 times 6x plus 5 to the power of -1. And oh, sorry, all of this prime, and this is equal to 6. Sorry, -6 times 6x plus 5. Oh wait, hold on. Is it the chain rule here? Oh boy, wait, I don't know. No, I actually do think so. Yes, it's a chain. It's the chain rule. So we have 6 times, and then the chain rule begins. So we have the derivative of the outer function negative 6x plus 5. Wait, hold on. Of the outer function to the power of -2 times the derivative of the inner function, which is simply 6. Yes. Okay, perfect. Um, yes, that's it. 6 times negative, open up parentheses, 6x plus 5 squared, whoops, to the power of -2, negative squared, times 6. Beautiful. Final question. A final question. Okay, this is a word problem, so I got to be careful. I'm not that good at word problems. And how long do we go? We go 1 hour and 18 minutes. Okay, we're good. If a ball is thrown straight up into the air with an initial velocity of 50 feet per second, its height in feet after t seconds is given by y equals 50t minus 16t squared. So this is basically y of t because this is a function in respect to time. In other words, the function changes when the time changes. So this is basically y of t. That's the way I like to imagine it, minus 16t squared. Easy. Find the average velocity for the time period beginning when t equals 1 and lasting 0.1. Okay, so this problem was a little more complicated. So this is what we're going to do. So the question is asking us to find the average velocity for the time period beginning when t equals 1. So it's asking us from t equals 1 and lasting 0.1 seconds, 0.01 seconds, and 0.001 seconds. So this means that I need to find the average. The average of I need to find the derivative of the function at y of 1 and uh and the derivative of the function at y at 1.1. So here we have so let's just calculate the derivative. Y prime of t equals a simple 50 minus 32t. That's our derivative. So let's evaluate it at y prime of 1. Here we simply get 50 minus 32, that equals to 18. That's y prime of 1. I think we're going to need our calculator here because I don't know if you guys can see it. It's fine. Hold on. So we have 18. So our yeah, I'm just gonna so we have 50 minus 32t, and when t equals 1.1, 14.8. So now y prime of 1.1 equals what? Well, wait, what? Oh, what's it equal to? 14.8. Whoops. 14.8. So we added these together. They're asking for an average. So we're going to do 18 plus 14.8 over 2 because they're two numbers we're trying to find the average of. And yeah, I don't think we need a calculator. This is equal to 32.8 over 2 or 16.4. So I'm just going to put that in. 16.4. Yeah, right? Yeah, I'm missing anything. I'm just going to take that off. Now I'm just going to take this off. Cool. So that's our average. But then we also got to find it for 0.01 and 0.001. So we know that. Oh yeah. Wait, no. I'm sorry. It's important. Y of 1, y prime of 1 equals, what was it? 18. 18. Whoops. 18. And here, and I'm just going to use the calculator to find the derivative. Where is it? There we go. So now, at 1.01, and that's 17.68. Oh, whoops. 18 minus 17.68 over 2. What? Hold on, I'm confused. What happened? I'm sorry, let me just check this real quickly. Why did I get 0.16 and the other one got 16.4? That's odd. Hold on. So if I do 14.8, so 18. Oh, my bad. I'm supposed to do plus. So that's 17.84. Perfect. Okay. Oh, and now we simply got to evaluate it for 1.001. That's 17.968, 17.968, and that average is going to be 17.984. So, all right. Yeah, I know I did this like off camera, but what I did was simply find the average of the times they gave me, and now I simply have to find the value of the derivative of y prime of 1, and that's 18, right? So that's what we found. Yeah, so we found the derivative at 1.01, 1.001, and then 1.0001. Yeah, that's what we did. So these numbers are getting smaller as we go towards them. And then finally, when we get to 1, we get 18. And we can observe that behavior as we calculate the derivatives with these values tending to 1. So it's basically like a limit. And we got that right. Let's go. Why do we still have an 84%? Hold on. Here, I'm just going to all right, I'm a lot. I'm just gonna stop sharing for a second. How do we? No, dude, stop. I'm just gonna stop sharing. There you go. Here, I'm just gonna share back again because why not? My entire screen. There we go. So, I think I got 15 out of 16 correct. Oh, we got one incorrect. Dumb. My grade. Oh, let's see what we got for that one. I got 15 out of 16. Oh, that's still an 84.38 out of 100. That doesn't make sense. Hold on. Let's open a Desmos. 15 out of 16. Yeah, I'm supposed to get like a 93 on that one. Why did we Oh, it didn't. Are you going to update or not? You're not going to update. It's fine. Well, I mean, we should have gotten like a 93 or something. Well, I think that's it. Thanks everyone for joining. That was a lot of fun. That was, I think, an entire practice exam in an hour and a half. Yeah, it took quite some time, but it was a lot of fun. Thanks for joining, and I will see you all later.